Do you know that water is the weirdest liquid on earth? It behaves in a very strange manner. But why it is called so? Actually, water exhibits several unique properties which are not shown by any other liquid substance. Let us understand this. Water does not shrink when cooled below 4 degrees Celsius, unlike the most substances which get shrink when cooled. But what is the reason behind this? When water is cooled, it shrinks up to 4 degrees Celsius where it shows its maximum density. But as it is cooled further below 4 degrees Celsius, the intermolecular hydrogen bonding present in it forces the molecules to form an expanded open hexagonal cage-like structure, that is ice. And this hexagonal cage-like structure traps air into it, which makes ice lighter than water. And that's why we see that ice floats over water. Due to this unusual expansion of water when cooled below 4 degrees Celsius, ice forming on the surface of water bodies acts as an insulating layer. And this insulating layer prevents the freezing of water below and keep it warm. This helps the aquatic life to survive underwater at very low temperatures. Just imagine if this unusual expansion of water would not be there, oceans would have frozen up completely. This unusual expansion of water offers significant ecological advantages, but it also poses tough challenges. It can cause pipes to burst, roads to crack, and sometimes the breakdown of buildings and bridges too due to the frozen water trapped inside. When ice melts rapidly, it can lead to floods, causing a big damage to ecosystem. The intermolecular hydrogen bonding that causes this unusual expansion of water is also responsible for the unexpected readings for boiling point and freezing point of water. According to the molecular formula of water, it is expected to boil at minus 80 degrees Celsius and freezes at minus 100 degrees Celsius. But actually, the situation is different. It boils at 100 degrees Celsius and freezes at 0 degrees Celsius. But these unexpected boiling point and freezing point values are crucial for sustaining life on our planet. In the list of the unusual features of water, the next is its high surface tension. It makes the water really sticky that helps the insects to walk over it. This feature is also again due to the extensive nature of network of intermolecular hydrogen bonding. Water molecules are pulled into a shape with minimum surface area, causing the water droplets to form beads over petals and leaves. Another important feature is the high specific heat capacity of water that not only helps us to regulate our body temperature but also keeps the earth climate moderate and stable. Another important feature is the polarity of water. Water has excellent ability to dissolve many substances due to its polar nature. And it is vital for the biological reactions within cell and also for the transport of nutrients and waste product, and it also explains the way it flows through our veins in the form of blood. The unique combination of its physical properties like high specific heat capacity, heat of fusion and heat of vaporization, and the moderate range of temperature and pressure on Earth's surface helps water to exist in all the three states, that is liquid water, solidite, and the gaseous steam form. This feature plays a vital role in the climate of our planet, ecosystem, and maintenance of life process. Till here, we have discussed almost everything about the weird nature of water. But we have yet to know the root reason behind all this. You know that from the recent research studies, it has been revealed that liquid water is not uniform. It actually exists as a dynamic mixture of two different structures: a dense disordered form and a lighter, more ordered tetrahedral form. In the dense disordered structure form, hydrogen bonds are short, making the water denser. This form is often associated with high temperature or high pressure conditions. Now, in the light tetrahedral structural form, water molecules are arranged in more open tetrahedral network, and this arrangement is less denser due to large space trapped within this network, and it is seen in the form of ice. It is more likely to form at lower temperature and moderate pressure conditions. Actually, in liquid water, the two forms exist in a dynamic equilibrium. But you know that these two structural forms keep shifting into each other with the changing conditions of temperature and pressure. And that's why when water is cooled below 4 degrees Celsius, the proportion of light tetrahedral structure increases, which in turn decreases its overall density till it freezes into ice at 0 degrees Celsius. So what we have concluded? The dual structure hypothesis is the underlying reason behind the strange abnormal behavior of water.